Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today's topic is about SAS macro series part 10, and in this we are going to discuss about scope of macro variables. This is the last part in SAS macro series, and I also believe that this is one topic which each macro programmer should understand in detail. If this concept is not understood in detail, then there could be some problems. What are those problems and other things we will discuss very quickly. And now let us quickly talk about some theory. First, let's talk about local and global scope of macro variables. And in here, I have used the word generally. Means whatever I am going to discuss, this is accurate or correct to more than 90% of the times, but 10% of the time this is not exactly right. And what are those scenarios we will discuss. But first let's look into some theory. Macro variables created inside macro has local scope and they belong to local symbol table. And macro variables created outside macro has global scope and belong to global symbol table. Now, macro variables are stored in symbol table and these symbol tables are nested. Local is nested in global. Now we have covered enough of this theory. Now let us look into some description of this and some examples. Now this is the symbol tables which I was talking about, wherein the macro variables are stored in global or local symbol table. And if you see the global symbol table, local symbol table is nested in local, and all the macro variables created in global is also available in local, but whatever are available in local are not available in global. That means macro variable which we create outside of the macro are available outside of the macro, and also they are available to that particular macro. Whenever I use local, it means that particular macro in which macro variables are created. Now let us move forward and try to understand this better with simple example. In here I am creating a macro variable and I am saying %let a equal to my test. And in here I have a macro also, and in here I am creating macro variable and I am saying %let b equal to your test, and I am also doing a %put for macro variable a and also for macro variable b, and I am writing %ment. And this macro explain I am executing. Once I execute, I can see the value of a my test and also the value of macro variable b your test. So this explains us that the macro variable which I have created outside of the macro I can use in here, and I can also use the same macro variable which I have created in the same macro. This is nothing special. Now let us try to do %put ampersand a and ampersand b outside of the macro, and let's try to run this piece of code. And once we run this, we get one warning. It says that apparent symbolic reference be not resolved, which means the macro variable which we have created in this particular macro is not available outside. Now let's conclude this slide by 2 points. The first point is, whenever we create a macro variable outside of the macro, what it does is it creates a macro variable in global symbol table and it is available everywhere, and it persists or it stays throughout the SAS session. But whenever we create a macro variable inside a macro, what happens is it goes into local symbol table and it is available only to this macro and also it persists only when we execute this macro. Now if you want to access this macro variable outside of the macro, to do that also is simple. All we need to do is we need to use a percent global statement followed by the macro variable which we want to make it as a global macro variable so that it is available outside of the macro also. Now once we run this percent let statement followed by compiling this macro and then executing this macro, and if we do a percent put ampersand a and ampersand b, and if we run this percent put also, we can access both these macro variables and you can see from the results which I have pasted in here. By doing a percent global followed by the macro variable name in a macro, I can access this macro variable anywhere, which means pretty much it's a global macro variable. Now that we have looked into percent global, now let us look into a different aspect which is very interesting. Now in here I have percent let a equal to my test, and in here I have a macro wherein I am creating a macro variable and I am saying percent let a equal to your test. So here the problem is we have two macro variables with the same name, and scope of this macro variable is global whereas the scope of this macro variable is local. Whenever you have two macro variables with the same name, there is a problem. Now let us try to understand that problem. First, when we run this percent let statement, and it creates a macro variable which will have the value of my test. Now once we compile this macro and once we execute this macro, what will happen is this local macro variable value, what it will do is it will override this macro variable name and this value will become your test. Now let us quickly go 3 to 4 slides back, and then we are here. And in here we have a macro variable a and its value is my test. And once we compile the macro explain and then execute this macro explain, what will happen is here also we are creating macro variable a. What it does in here is it always looks into a level up. In this case it is global. So what will it do is this macro variable a, it has a value of your test, it will go ahead and update this value also. So this is a problem. And if you see in here, when we execute this particular percent put statement, you can see that the value of macro variable here is your test. Means this value has overwritten this value because we can access only a global macro variable outside, and this is a local macro variable and this has overwritten this, and this is a serious problem, especially when you are trying to build a lot of macro variables inside and outside of the macro. The conflict between the macro variables is real and it's problematic. Now how can you avoid this so that this macro variable will not go and update this value? This can be easily done with the help of percent local. So whenever you create a macro variable in a macro, if you write a percent local and mention that macro name, what it will not do is it will not look into this global space and it just get restricted to this, and it doesn't care whether the same name macro variable is here. So the way to avoid the conflict when you have the same macro variable is by using percent local and the macro variable name in here, so that now we are kind of protecting our global macro variable. Now once I run this percent let statement followed by my compilation of macro and execution of macro, and then I do a percent put ampersand a, the macro variable value will be my test. So this value is kind of protected from this local macro variable by simply writing percent local and the macro variable name. So more than often SAS macro programmers don't use this percent local very much, but it's a very good practice to use percent local whenever you can think of there could be a conflict and there can be a chance of overwriting global macro variable. Now let us look into another factor related to local macro variables. In here, to understand this, let's look into an example. In here, I have percent let t equal to hello, means I am creating a global macro variable in here, followed by a macro in here, and here I am naming that macro as one more, and in here I am using a macro parameter, and this is a keyword parameter. And in here we are also creating a macro variable t, and then when we execute it with a particular value, we are giving it a value in here. In here I am passing a value high, and once we run this percent let and then we compile this macro and then we execute this macro by passing a parameter, we are creating a macro variable, a local macro variable. This local macro variable will never look into global symbol table. Unlike when we use a percent let, percent do, or prox equal into clause. So this is very important to know. I have not told anything about call symput or call symputx. It's even more little trickier, and we will have a separate topic on call symput. And then what will happen is when I do percent put ampersand t, we are accessing this macro variable, and we can see in here once we execute we have the value of hello. So this macro variable which has the same name doesn't override this macro variable. As I said to you, macro parameters only look for local symbol tables. They do not try to update global symbol table. Now that we have looked into this aspect, now let us get a little bit deeper. Now let us discuss about overwriting of macro variables when we nest macros. To understand this concept, let's look into an example in here. In here, I have two macros. The first one is test2 macro, in which I am creating a macro variable g, and it has a value of y. And also I am doing a percent put and saying ampersand g of macro test2. And in here I have another macro, and this macro is test, and in here I have a percent let statement. In here I am giving the value of z to this g, and also I am executing this particular macro, and also I have a percent put ampersand g of macro test, means I just want to access this macro variable in here, and I'm closing this macro with the percent mend. And when I execute this percent test, what will happen is first this macro variable g which belongs to test will get created, and then this percent test2 gets executed, and this test2 has another macro variable g which has a value of y. And what these particular test2 macro variables will do is, as it is nested, it will overwrite the above macro variable or the above level macro variable. which has the value of z. And when I do the percent put ampersand g of macro test, as we have created the value of macro variable z with y, it overwrites the macro variable a level up, and then both of them will have same value. It is the same thing what we have seen earlier. It is overwriting of macro variables to the level up. Now let us try to understand this pictorially. In here I have a symbol table, and in this symbol table this is a global symbol table, and test2 is nested within this test macro. If you see in here, we have test, and test2 is nested within this test. And in here, our test2 has the value of y. So what it will do is, even though we have created macro variable with value of z, this value of y also looks into this and it will update it. So again the same problem of overwriting. Earlier what we were looking was, we were looking into a local macro variable and we were looking into a global macro variable, and overwriting of local macro variable to the global macro variable. Here what is happening is, a nested value updates the higher level local macro variable. Now I do not want to go too much into nested macros. I have never written a nested macro myself, and I just wanted to tell or give this information out. So how do we avoid this? It's the same way. We are going to do a percent global, and then we are going to mention the macro variable here, and then once we nest it, it will stay local to this one only, that is to test2. It doesn't overwrite, and once we execute this percent test, in the log you can see the result as in here. You see in here the value of test2 is y, whereas the value of macro test is z. So nothing has been overwritten. So this is an important point to remember, whereas in here it was overwritten. Now by this you could understand the importance of percent global and percent local. Now to explain about scope of the macro variables, we also need to discuss about call symput. Call symput and call symputx are little different. Now let us look into the first category where I want to discuss about macro variables created by call symput or call symputx in a macro. In here if you see, I don't have any parameter. Whenever we do not have any parameter and we use call symput, we are going to create macro variables in global symbol table. The reason for this is, whenever we use call symput or call symputx, it cannot create a local symbol table on its own. It has to be created first for this particular macro. To do that, we can have a parameter. If we do not have parameter, call symput and call symputx will create these macro variables in a global symbol table. And once I run this particular macro, or I compile this macro and execute this macro, I can access these macro variables outside of the macro by simply using percent put and using the macro variable names here. And you can see I can access these macro variable values. I have made a very detailed video about call symput and call symputx, and link for the same I will give in the description below, and I would not like to talk about call symput and call symputx in here. I just want to talk about the scope. And in here another important point to remember is, whenever we use a percent let statement, a percent do loop or proc SQL into clause, even without parameter, they create local macro variables. Only call symput or call symputx is little different. And it creates global macro variables even in a macro. And this is an important point to remember. If it creates global macro variables, how we can make them local macro variables? You know that is very simple. All you need to do is you need to use a percent local. We have discussed about percent local before. Now I would like to show you something different in here. Call symputx allows one more argument. That is, it can have three arguments. The first argument is a macro variable name. Second argument is macro variable value, and third argument is scope of the macro variable. As I said to you, in here the macro variable is going to be created is a global, but I set the scope to be local. And another way is simply using a percent local and mentioning this macro variable name. But here we are doing it through third argument, and we are saying L in here means local. Now if we try to access this macro variable outside of the macro, we will get a warning saying that this particular macro variable is not there. That is because it is now a local macro variable and it cannot be accessed outside of macro. Now we have looked into this aspect. Now let's try to look something different in here. Actually, this is something very similar to other macro variables which we have created in macro. Here we have very similar kind of macro, but in here we have a parameter. It does not matter what parameter this could be. If this macro has a parameter, and this parameter will create a local symbol table, and this local symbol table, what it will do is it will help these particular two macro variables to go into local symbol table. So now what will happen is, now when we pass the value of the macro variable in here, that is var equal to hello world, these two macro variables also go into local symbol table along with var. And when we try to access them outside of the macro, it will fail because these two macro variables are now of local scope. To make these macro variables global, it is again simple. In call symputx, we can give an additional parameter and we can say G. This creates a global macro variables. And another way to do is simply writing percent global and writing the macro variable name. So to reiterate the whole thing, I just want to tell in one line. Whenever you do not have any parameter, call symputx or call symput will create global macro variables. Whenever you have a parameter, it is going to create a local macro variable. And the reason for that I have already discussed, that is call symput and call symputx on itself cannot create local symbol table for that particular macro. So it needs the help from parameter. And one last thing I would like to say is the third argument option is only available for call symputx, not for call symput. And also whenever we use call symput and we want to change the scope, all we need to do is we need to use percent local or percent global as we require. That's all for this topic. If you have liked this topic, please give it a thumbs up, share and subscribe. Thank you.